Hi, this is a presentation on flying cross-country and doing field landings. So, we want to go and fly cross-country. One of the consequences of that in gliders is we can't always stay airborne. So the question is, how can we fly cross-country safely, even if sometimes we need to land out? And if we know how to do that, it's going to make cross-country flying much less stressful and much more fun. So this is what we're going to go through. That's our agenda, how we can stay safe while flying cross-country. The first point is that we're always going to be in safe glide of at least one safe landing option. If we need to land, we're going to select a good field. We're going to use all the methods we can to estimate our height above that field. We're going to use decision height at which we commit to a landing. If we've got a turbo, we'll just make the assumption that it won't start. When we're low and we've got a field, we won't lose that field and we'll fly a good circuit. And we'll talk a bit after all that about the threats and the errors that might happen during this process. So we're always going to be in safe glide of at least one safe landing option. So what I mean by safe glide is that we're always able to arrive with enough height to do a circuit, even if we fly through sync, and we'll go into how we do that in a moment. Our tactics about how we fly are going to depend quite a lot on the height that we've got and the terrain that's underneath us. And that height that we need is going to depend a bit on our landing place, because if we have an airfield with air traffic control as our landing option, we need to arrive with enough height to fit into traffic. If we're going to a farmer's field or an airstrip or something like that, we might need to arrive, or we will need to arrive with enough height to inspect it. Okay, let's have a look at the safe glide. So we want to be able to arrive somewhere that is landable with enough height for our circuit. Now the gliders we fly typically have best glide ratios of somewhere between 30 to 1 and 50 to 1. You ought to know what that is for the glider that you're flying. But sync and wind have a big effect on that. So this little table here, if we've got a glider that has a best glide speed of 55 knots, and glider 1 has a 35 to 1 glide angle, glider 2 40, glider 3 50, then the effect of a 15 knot headwind on that is quite significant. It drops that 35 to 25, that 40 to more or less 30, and the 50 to sort of 35. And just one knot of sync on the way has a big effect as well. It drops the 35 to 21, the 40 to 23, the 50 to 26. So you can see that headwind and sync make a big difference to our glide angle. So we better not assume the actual glide angles of the glider. We need to use something significantly reduced. And if we're in somewhere like the mountains where we might have wave, these numbers could be quite a lot worse. But a good number to use for the sort of flying that we do from Cambridge is to take something like half best glide performance to a safety height. So if we've got a 40 to 1 glider, we'll use 20 to 1 and we'll have a circuit height, perhaps 800 feet at the beginning that we need to get to. So at any point, if we program our nav computer properly or do the sums in our head, we can tell whether we are within safe glide of a particular landing option. Now it's possible also to use the arrival height on a nav computer, but there are some issues with that because it's using the expected performance of the glider to give us that height. We can put some margin in that by using a high McCready setting, but be careful. Now how we go about this is going to depend on the height that we have and the terrain underneath us. Let's start with the easy one. If the terrain is good, So there are lots of fields, and maybe we're not at the time of the year when those fields are full of difficult to land in crops. So basically everywhere we fly, we're going to be in range of a landable area. Perhaps below us, definitely ahead of us. So when we're high, well, that's all we need to have. We need to know that there's a landable area where we're going, and we're confident that there will be fields within it. And by high, in that case, I mean above 2,500 feet. We get a bit lower, let's call it medium height, and we're going to want to know that there are a specific set of fields that we can see. So between 1,500 and 2,500 feet, say. I need to be able to look ahead and say, yep, I can see a landable area ahead before I progress. And I have in the past, when the crops haven't been so good, looked ahead, been unable to see landable areas, and then turned 90 degrees to a known good landing place. And then lower, we need to have a specific field that we can land in, below 1,500 feet or so. Because I can't, if I'm low, I can't go very far to find a new one. If the terrain is less good, those height bands can go up, so we maintain the safety of those options. Or, if I'm not confident about that, we need to be able to divert to a known good option, somewhere that we know to be landable, an airfield perhaps. And if the terrain is poor, in the mountains for example, or over forest, then we need to have specific known landable fields in the nav system that we know we can get to. So our tactics depend on what's underneath us and how high we are. Next, we need to make sure as we do get low, we select a good field. How do we do that? Well, it's important to know what the wind is, and we try and know what the surface wind is at all times when we're flying cross country. So there's some things that we can use for that. What's in the forecast? What was it when you took off? We might be in a different place, but it's a clue. What is it at the height we're flying? Our nav computer will tell us that, as will the movement of the cloud shadows. The surface wind is probably backed 30 degrees or so, and maybe half the strength of the wind at height. There might be some visual clues. Smoke or wind turbines. If we're in the mountains, be really careful because, as you will hopefully know, the surface winds vary a lot because of valley winds and valleys and so on. Now, I'm not going to go in this video in any depth into field selection because there's a tremendously good set of BGA field selection videos which we've linked to on the website. I'll just remind you of the size, slope, surface, shape and surroundings 5S's mnemonic, which is a good place to start. But make sure that you're very familiar with those videos. The other link we've got on the website is about crops, and there's a good website that takes you through different types of crops and what they look like at different times of the year. One of the things that you can do is study fields on the ground as you're driving around to and from the airfield and at other places, and that's always quite interesting. Think about, look at every field and say, can I land in that? I find it quite useful. So we've got our field and we're getting lower, and it's important to know how high we are above the ground. Now, when we do the cross-country endorsement, you'll be doing your approaches without the benefit of an altimeter because we want you to be able to make a visual estimate. But actually, it's really quite difficult to be accurate using a visual estimate, especially if there are cues missing or they're different from what you're used to. People will talk to you about, for example, looking at a house and being able to see the fact that there are window panes and not just windows. But that's only convenient if there's a house below you. You can make a reasonable estimate of your height at Gransden, but that's because you know exactly how big things are and you've seen that picture before. You go to a different part of the country where the fields are of different size, and your cues are all screwed up, so you're not going to be able to do very well. So as you get lower, if you don't have any other aids, then distance and angle are probably the important things to use for a good estimate of height, or at least if you're in the right place in the circuit. But although we will teach you to do these two things, what I really suggest you do is use the tools you've got. So the first one is I always have a nav box on my GPS which tells me my height above ground, and it does that on the basis of where it knows where we are, it knows how high we are, and in terms of altitude, and it knows what the height of the terrain is, and that works well around southern UK because generally the ground height doesn't change very much. If you're in hills, it's less likely to be useful because the ground underneath you might be quite different from the ground altitude of your landing place. But if you're in mountains, you'll probably know the altitude of that landing place anyway. The other thing you can do is you can look at your altimeter and take it the altitude and take off the expected height of the terrain, which works quite well around the southern UK because you know roughly what height the terrain is going to be in different places, within a couple of hundred feet at any rate. So if we're out to the east, for example, over the fens, the terrain is largely under 100 feet. And that's close enough for this purpose. By the way, we are flying on QNH, which will tell us, it means that our altitude is shown on the altimeter. That is our height above mean sea level. Showing the height above Gransden's airfield is not particularly useful. We need a decision height below which we commit to landing. So as we get lower, typically we are looking quite hard to find a new climb. But there comes a point when we have to throw that away and say, right, I am now committed to landing. And even if I fly through some lift, I'm going to land. And we need to do that early enough that we can inspect the landing place if we haven't done it already. And we do need to leave enough height to do a decent circuit. If we've got a turbo, the correct assumption is that it won't start. So we manage the flight, all the things I've talked about so far, in exactly the same way as if we were in a pure glider. It's entirely the wrong thing to do, to think that you can change that just because you have an engine. Probably our decision height for landing or starting the engine is now higher than it would be in a pure glider. At least it is for turbos as opposed to jets and fezzes, because we need to allow enough height to start the engine. Now, this is going to be very dependent on the type of sustainer or engine you've got. The jets and the fezzes don't take much height to start, and you can be flying a circuit while you're doing it. Some of the turbos require that you dive to start them, and that's going to burn height. The other problem is what happens if it doesn't start, and turbos in particular, if you've got the prop out in the slipstream, your glide performance is much worse than it normally is. So you've got to be able to land with that extra drag. You should practice that back at Gransden so that you know what that picture looks like. You might need to allow enough height for a second start attempt, and if you don't have it, don't try that start attempt. Let's imagine that we've got pretty low. We know which field is our landing option, but we're not quite down to decision height. And we found a little bit of lift, a half a knot. So we are trying very carefully to climb in our half a knot. We need to be aware of a couple of things here. One is, it's only half a knot, so we've spent 10 minutes gaining a few hundred feet. And we think if we move, we can get into better conditions. Well, that's fine. Or we might be drifting with the wind as we climb in our half knot. And the danger is we will get too far away from our landing option. So there's two things that we can do. One is maybe as we drift or as we move, we can see another option for landing. So we select that new field, and that becomes the field that we're going to land in if we get below our decision height. Alternatively, if that isn't available, we have to land in the field that we first chose. We don't want to get in a situation where we are no longer in a position to do a good circuit into the one field that is available to us. And then we need to fly a good circuit. I'll repeat my point about knowing the wind. What's that circuit look like? Well, if the field is a little far away from where we were, it's quite good if we can fly upwind past the field because we can make a good inspection of it before we go downwind. We want to choose a landing area well into the field if it's big enough. Landing somewhere in the middle is better than landing at the edges because there tend to be fewer obstacles. And then we need to do a proper circuit, a sensible high key position at the right height, a proper circuit, not getting fixated on where we're going to land, looking over the nose in turns for reasons we'll come to. And don't forget that a 1/2 to 2/3 air brake approach leads to a shorter landing than a shallow approach. So we're doing a conventional circuit with a 1/2 to 2/3 air brake approach, wings level at 300 feet above the field. The thing that we do every day back at Cranston. And then after landing, if you've landed in an airfield or a strip, move your glider off the runway so the next person can land. Contact the owner. Think about contacting the distress and diversion cell at London Information if you think that people might have called you in as a crash. Contact the club, let them know. If you don't have mobile signal, you can use the radio to relay a message on one of the gliding channels if there's no mobile signal. And it's worth having a notice to put in your canopy, just a sheet of A4, saying you're okay with your mobile number. So when you go walking around to find the owner, people can call you. Let's have a look at the threats and the errors. So threat and error management. What can go wrong? And there have been tens and tens of thousands of field landings in this country, and some of them have gone wrong. So let's learn the lessons from those. We're going to talk about a good field not being available, the field choice being left too late, people being under too much pressure, leading to a loss of speed in the final turn with a stall spin, unforeseen obstacles or hazards in fields, or engines not starting. So the good field, okay. Maybe there are a few good fields, either because the terrain is bad or because what fields there are full of crop. And there's an error associated with that threat, which is that we discover too late that there isn't a suitable field when we need one. And the consequence is a crash, maybe with a fatality. And the mitigation, though, is planning ahead. We make the routing decisions where we're going to fly on the basis of where the landable options are, and we don't go into places where there aren't any landable options. Leaving the field choice too late, the error is we try too hard to stay airborne, and there's lots of examples of people doing this, trying to thermal down to a small number of hundreds of feet, and then making a very late field choice and going straight in, so they don't get to inspect the field as part of their field selection process, and they crash. And the mitigation is choosing a field early and then not losing it because you've drifted away once you've chosen it. Next one, a common cause of accidents. People crash doing a field landing on the approach. And the obvious error there is that they're too focused on the field. They're looking at where they're going to land. And they forget the basics of flying, which is that when we do a turn, We look over the nose so that we can maintain our attitude and maintain the speed. And consequence is a stall, a spin, and a crash. And again, that can kill people. And the mitigation is making sure we fly a proper circuit to reduce the pressure on us as we do that landing. And we look over the nose and maintain attitude and speed during the turns. Unforeseen obstacle or hazard in the field. It's a threat, really. Consequence is generally damage to the glider. Difficult one to mitigate. A good inspection is going to help. And picking a big field and landing well in helps too. But sometimes it is one of the consequences of landing in fields. And lastly, engines not starting. Sustainers in gliders are not hugely reliable, and it's not uncommon for them to not start because of a technical issue, or because people do the incorrect start process because of pressure. Some are relatively complicated to start. Others require you to fly at certain speeds, and if you don't do that, they won't start. And the consequence of that can be quite severe, particularly if people haven't been applying the rule of not relying on the engine, and people can crash with fatalities. So the mitigation is a safe decision height for the engine start, making sure you're in a sensible place, and for a turbo, something with a propeller, big propeller that's going to create drag, you need to be pretty much above your landable field, less important for a Fez or a jet. You need an early decision to land if that engine doesn't start, unless you've got enough height and you know you have enough height for a second attempt. And practice with the engine extended, again for the turbo, which has drag. So that's it. If you do this process properly, then flying cross country becomes a pleasure rather than stressful.